Hello everyone. Let's look at an example. We will be looking at problem F5, fundamental problem 5-7, and this is on page 261. And let's go ahead and work through this problem, see what we have. So the problem states the uniform plate has a weight of 500 pounds. Determine the tension in each of the supporting cables. And if you note on there, there's also a 200-pound force acting on the plate. If you look at it from the origin, the x direction would be 2 feet, the y direction would be 3 feet, and there would be no change in our z, except for that it's going down at 200 pounds. So we are trying to find in this problem the tensions in each cable. Okay, so my approach is a free body diagram, and then to use my equilibrium equations to solve. So I am going to cheat because it's really hard for me to write on this tablet. So if I were to draw my free body diagram, I would just incorporate these forces here and leave everything else the same. And then I would say that TA, that's tension TA, this is tension TC, and this is tension TB. And we also have this force of 500 pounds, the weight of the actual plate. So let's not forget our 500 pounds. So this would be my free body diagram, taking the rest of these cables off and drawing this out as needed. So my solution is as so. I could sum my forces in the z. If I sum my force in the z direction, I'm going to have TB plus TC plus TA minus 200 pounds, since I've got this 200 here, minus 500 pounds, the weight of the plate. Now, this is kind of unlike two-dimensional. We just write out all of our equations that we know with our unknowns to see what we can solve for. Normally, you can't solve your moment about a point to solve for one and then kind of work your way around that. So this is kind of my process on how I go through it. So I sum my forces in the z. Now, remember I had those 6 equations. I had force in the x, force in the y, force in the z, moment about the x, moment about the y, and moment about the z. So really, if I did anything in the x and the y, am I going to get anything? No. So I can really count those out. If I sum my moment about the z-axis, meaning here, am I going to get anything? No, those are all going to be 0 as well. So I can sum my moment about x and y, and you'll notice I'll have rotation here, and I'll have rotation here. So rotation here, and rotation there. So I will use my equation, sum my moment about the x is equal to 0. Now when I do this, I'm going to say TC. Now here's TC. Now I am summing it about the x-axis, so my distance is 3 feet, and it is rotating here, which is going to be a positive. Okay, remember, counterclockwise. TC times 3 feet minus 200 pounds times 3 feet. Since this distance again is 3 feet here, stays the same, but it is rotating clockwise. So it is a negative 3 feet times 200 pounds. And then I have plus TA times 3 feet. And then I have minus 500 pounds. Now the distributed load would be right in the center, so it's going to be half of the 3 feet. So that would be 1.5 feet. And remember that it is also negative because it is causing a rotation down. Now, do we have to worry about tension TB? No, since it is sitting right on top of the x-axis, there is no perpendicular distance, so we can eliminate that one. If I sum my moment about the y-axis, I'm going to get negative TB times 4 feet. So I go from here all the way to here. There's my TB, and it is rotating negatively. It is rotating clockwise around the y-axis. So if you spun it, this would be your point y, right? And y is going into the board. And then you'd have your z-axis here, right? And your x-axis here. So this TB is going up, so it is rotating clockwise around that point. So TB times 4 feet minus TC times 4 feet plus 200 times 2 feet plus 500 times 2 feet is all equal to 0. Now I'm going to organize my work here, and I'm going to come in and say TA plus TB plus TC is equal to, and I'm going to take these over to the other side. So let's just, that's equation 1, equation 2, equation 3. So I'll have equation 1, equation 2, and equation 3. And all I'm doing is rewriting my problems so that I can easily solve for them. So now I'm going to have, so if you notice, I'm going to put TAs all together, TBs together, TCs together, and then everything else off to the right. So over here I'm going to have 3 feet times TA plus 0. Since here I have no TB, I'm going to go ahead and leave it as 0 plus 3 feet times my tension of the cable in C is equal to 1,350 pounds. So negative 500 times 1.5 minus 200 times 3 is 1,350. I move it to the other side. Alright, and my last equation, equation 3, I have no TA, but I do have a TB, which is negative 4 feet times TB minus 4 feet times TC, and that's all going to equal negative 1,400 pounds. So what I have here is I can set up a matrix. I can set up a matrix using this instead of trying to use substitution and elimination. So really what you have is 1, 1, 1, 700. You have 3, 0, 3, 1,350. And then the last one I have 0, negative 4, and negative 1,400. And then keep putting this into my calculator, you know that you're solving for, these are all TA, TB, TC. This is A inverse of the negative 1 times B. To solve for this in your calculator, you get A inverse times your B, and you get that TA is equal to 350 pounds. TB is equal to 250 pounds, and TC is equal to 100 pounds. Make sure that you put that in your calculator. Make sure that you get the same answers. Make sure that you're setting up your calculator right in order to help you with your quizzes and your exams. Alright, that's my first example. I'm going to do one more example for these 2 chapters in order to help you. Please let me know if you have any questions. Post them on the discussion board. Thanks.